Hi everyone, welcome to the Tech Target. And today we are going to talk about the decoding the data automation with cloud native analytics pipeline and MLOps. I'm Saurabh Srivastav. I'm senior leader with AWS Solution Architect, and I'm also author of the Solutions Architect Handbook, which is one of the best-selling book in Amazon.com in cloud native and system design category. So today we are drinking from the data fire hose. So data is everywhere, and these data is coming in exponential way. Data is coming from all the sources like social media, the website, the applications, the IoT devices, and there is so much data to ingest and get the insight from that. And data is new oil. So whoever get the most insight from data, they stay ahead on the competition. If you see all the large companies like Google, Amazon, Facebook, all of these organizations staying ahead in the competition because they are able to utilize the full potential of their data. And that's where we're talking about taking the organization to the digital transformation. So data automation is the key to unlock the digital transformation. But what is the data automation? It is about enabling the full capabilities of your data. And when you can do that, when you adopt the data ops and MLOps, because that's how when you automate the pipeline, then you get the faster insight and predict the future outcome, which make you leader in your segment. It's same like the DevOps. If you adopted the DevOps, you do the much faster deployment and do the shorter release cycle. Same way, DataOps, you get the faster insight or with the MLOps. But this is complex, right? It is a big task. So how can I do it? That's the question all the enterprises are asking today. Okay. So before going further, I just want to say that most of the architecture and talks are expert from the Solution Architect Handbook, second edition. And you have the QR code in the screen. You can scan it and grab a copy for you if you want to dive deep more on the details. It is 600 pages book and going in lots of details on the different concept and taking you gradually from the understanding the architectural concept to the modern technology like IoT, quantum computing, AI, machine learning, and also telling about the soft skills. Okay, so let's without much delay, let's move to next. So let's sing a song of data. So we'll start with basics. So this is a generic data pipeline at 10,000 feet level where you are ingesting the data coming from the different resources. You are collecting it, then you are putting it in a storage, and that storage could be object storage, SQL storage, MySQL storage. Okay, and then you perform some process and some analytics like data transformation you do there. You make sure, hey, my data don't have any duplicate, or it is data modeling is the format which can consume by the business. And then you go for visualization, which presented the data which can be consumed in that way, and then it provide the business insight. One thing is to notice as you want a faster data moving through this pipeline and getting you faster insight, so as such cost get increased. So if you are ingesting streaming data and want to get immediate insight like real time recommendation or real time personalization, your data pipeline cost will be more. Or if you are doing some batch data processing forecasting, okay, I will take last 1 year data and forecast how this year my sales look like, then that might be less costly. So I would like to stress when you're thinking about the data architecture, and this is one of the basic principles, to think about the flare data principle. And flare data principle, as name stand, it's start with the findability. It means you should have the centralized data catalog. All the metadata is there. Who is the owner? And people should able to discover the data. You need to have the data classification, whether the data is confidential or public, or how people can use that. And you need to put other mandatory attributes which is required by the data governance and compliance. The second is lineage. Lineage is very important. You want to know from where data is coming and from where it is going. There may be multiple hops of the data. Okay, it is coming from the one resources, then going other resources for the processing. Then might be third resource for the data warehousing, and someone else is consuming that. And these data flow you want to visualize to understand from what source data is coming and how it is getting consumed. The third thing is accessibility. So you need to have the proper security credential and only provide the access to the authorized people. Data is very sensitive, so you need to protect your data. Then interoperability, where you need to store the data in the format that can be consumed by most of the application. And the final things is reusability, where data is registered with the known schema. If one person have work in the data, other people should able to use that. Attribution of data source should be clear. So that's what the flare data principle, and that the basic things you need to consider when designing the any analytics or machine learning pipeline. So let's dive deep some tools for designing a big data architecture pipeline. And I have put some tools respected in the respect of whatever analytics pipeline we have seen in couple of slide back. So when we are talking to the data collection, it could be the streaming data which you want to consume at near time, or web application data, or you are importing data from somewhere. From storage perspective, object storage is very famous, like Amazon S3, where you can store petabyte and zettabyte of data and dump any kind of data there to to ingest immediately and consume later. Then there is other kind of data, the NoSQL data like DynamoDB is there, or DocumentDB or MongoDB. And real-time data store, maybe the Kinesis or Kafka, or managed streaming for Kafka. And then you have the IoT data and NoSQL and RDBMS, the relational data store. Everyone is aware of that. Then once you stored the data, you have several tools for the data processing and analyzing. Most famous one is Hadoop ecosystem, which include the open source technology like Hive, Spark, and using that you can transform your data and as per the business requirement. And then you can perform the machine learning on top of that. You can embed with the dashboard, or you can do that Hawk analytics like using the Presto or Athena. And then finally, the data visualization. There is a business intelligence tool like Power BI, Amazon QuickSight, Tableau, MicroStrategy. Few of these are the few famous tools which you can use and perform the analytics using the Elasticsearch or OpenSearch. Understand how to assess the data quickly. So let's look at some pattern. So, and after that, we'll talk about the more data automation. So, foundation, then pattern, and then automation. So, data lake architecture is become pretty prominent in last 2 3 years, and this is becoming very prominent and adopted by lots of organization because it solves several problems. So, few questions answered by the data lake is from where data is coming. So there is a multiple sources of data. Okay, and it is distributed many places. You want a single source of truth, and you don't want data should is to be stale and there is multiple copies and it is in silos. Okay, that can create a lots of problem if different domains or different departments of your organization using the different set of data, and those are not in sync. So that is answered by the data lake. Let's have the centralized single source of truth and ingest data from the various resources. The other is collecting and efficiently storing the data. So how can I ingest the data quickly from various sources? So olden days when you have these traditional data warehouse system or structured relational database system, any data is coming, you have to pre-process first and make sure that it is satisfying the schema defined by the relational database, and that slow the speed, and the especially for the real time data is coming, so many data coming from social media and all, you don't have days or to transform them. You first want to ingest them. So that's how the quick ingestion provided by the data lake, and it ingests in multiple format, whether it is in the XLS, JSON, Parquet, ORC, and you take the name. Okay, if you have the object storage, you can just ingest it, and then later you can figure it out, hey, what to do with that data. But you have that data store, and then you can efficiently scale the storage, and mostly in the decoupled manner. So it is no more the requirement. If you need more storage, then you have to buy the more compute. Okay, so that decoupling is also provided. And as volume increase, get generated more data, and you can have pretty much elastic data store, which will scale as more data is coming. And it happen instantly with the cloud. You don't need to b- order the hard drive or rack and storage rack and wait for like 3 to 6 months to get it. We don't have that time. The market is very fast moving. And once you have this, then you figure out, okay, apply the different analytics, take the machine learning framework and get the insight. So that's what, in one word, data lake is the central for all kind of data store, and then perform the processing analytics on that. Now then, here you see that architecture where data is getting ingested from the application file-based database, RDBMS. And if you will see that there is different tool, I took an example from AWS, but you have pretty much the same kind of services available with other cloud providers also. And so relational database, you use the database migration service to ingest. And then if the file-based database, if you want to do the secure file transfer, use the AWS transfer as for SFTP, and real-time database, you can use the Kinesis. Now in data lake, we talk about it is all getting ingested into the central data store, which is Amazon S3, very scalable, 11.9 availability, and very durable data store. And then on top of that, you can understand the business requirement. Other use Hadoop in the cloud, which is Amazon EMR, and provided you can use Hive, Fluent, and Spark, whatever is your favorite open source Apache software, you can use into the EMR, same like you use in Hadoop. And Glue is kind of serverless Spark cluster you get on demand. So that makes your job much easier. Then you process the data, store into the processed layer, and after that different department, or you can consume for the different purpose. So might be data scientist is coming and consuming for the AIML purpose using the SageMaker and performing some machine learning on that. The business analytics person is coming and using that into the quick site to visualize that, or doing the ad hoc query and getting the data insight, okay, to join more data if needed. And you can load the data into the Redshift and perform the large number of queries there, which is very scalable. And then you see the lake formation, which do the data cataloging and security governance, who should have access or not. And then here you see that at the bottom, you have different data encryption mechanism, like the key management system, and then auditing the data using the CloudTrail, or monitoring using the CloudWatch, and PII data monitoring using the Messi, or getting the notification using the SNS. So this is a data lake architecture. Now, a next evolution you might be hearing in since last year, last 1 or 2 years, is the lake house architecture. So it is data lake with data warehouse, and where you leverage the scale of the data lake to ingest and store large amount of data, as we have seen in the previous slides. But the same time, you enable the user friendliness of SQL queries and the reliability and uh, transaction robustness provided by the data warehouse. So some aspect of it, again, like data lake, you store into the open source format, storage and compute decoupled. Transactional guarantees is the one things which definitely Lakehouse architecture address that. And the main things, you divide duplication between the data lake and data warehouse. So you have single tool which can query the data from the both the places, or you can have some data in the data warehouse or directly consume from the data lake. You don't need two places to store the data. So here you see that cloud native lakehouse architecture in AWS. So data is getting ingested from the on-premise database to S3. And we took a example of the financial customer. So they have, this bank will have a credit data and loan data. And both department maintain their individual ownership, and then creditor can read the credit data using the Amazon Redshift, so or Athena, and then loan can processing a person can read the loan data. Some of the data we can, if we want, we can load in data warehousing, but other data we can leave into the S3 in process layer. And all these data processed by the AWS Glue, which is serverless Spark cluster. And then restless spectrum is kind of do the direct query in both places, the data warehouse, which is Redshift and Amazon S3, and joint that uh, data and provide you insight. So it's not like you are duplicating the data. If you want to process, you can directly query from the data lake, and also you can combine that with the data warehouse. Now, the next pattern we are looking recently, very recently, I will say in the last 6 to 8 months, is more talk about the data mesh architecture. So once we are talking about the data lake, and you need to have the centralized team for the data lake, and where all the data is getting stored into the central location, and one central team need to manage. But there is a little bit challenge there. First is become a single point of failure because of data lake is there. Then it slow down the process because you have central team. And there is a lots of back and forth happen for a domain, because that team might not understand the data model for the HR department versus the manufacturing versus the financial, okay, and or retail supply chain, and that expertise needs to come from the business owner. So there is lots of back and forth. So data mesh architecture is all saying that, okay, let's put the domain driven distributed data. So it says that everyone can have the decentralized ownership and treat data as a product. Okay, so and these product is owned by the individual domain experts. They are the ownership of the data, but the data governance like security and all will be centralized. So data governance and audit is centralized. So we know, we keep control who is assessing the data and how it is happening. And also data cataloging is centralized, and which is accessible by everyone. So people can understand what data reside where, but actual data can be served as a product owned by the different department. So the major difference between, you will see, the data mesh and data lake architecture is, rather than combine the multiple domain into centralized place, It is intensely left distributed. And it's also helped to share the data across peers, partners, academia, and vendors. A simple example, if talk about the pharma company and when they conduct the medicine research, they outsource that job to the other partners. And once they complete that medicine experiment and research, they upload data back to the pharma company, and then they take that data and kind of get the approval on top of that, whether that medicine or vaccine should go into the market or not. And that kind of exposure we can put through the data mesh architecture. So let's take a example on that, and this is in AWS. You see that here we talked about the data getting landed in the raw data store in S3, then we build the trusted and then refined it. And this all the data getting registered into the centralized data catalog, and where we have recorded the metadata information for the database and the table, and also in federated governance account, keep the track of the schema consistency, the manage the security and the role distribution and all those things. And then consumers pick up the data from the registered location and it consume that the way they want. It may be using loading into the data warehouse or doing the direct query. So the idea is that each department own their own data, expose it as a product which can be embedded or consumed by the different means. So let's go to the next and go beyond analytics and talk about the machine learning, because if we are talking about the data, the picture is not complete without the machine learning. And again, we'll start with the basic, the 10,000 feet, how machine learning happen. We learn lots about the analytics, and that's what we get the raw data here. We process the data and we label the data as per our need. And then it divided into the training data set and test data. We put the machine learning model like XGBoost and k-nearest neighbor or whatever is your need, and we train that model, test and validate that, and then that model is put the prediction for us, which we call inference also. And then we deploy the model endpoint in production and connect with the application, and boom, you get the start getting the insight and forecast about your data. It may be utilized for the hyper personal recommendation as a real time, or you create the personalization, or you create the real time forecast, or something like autonomous car, right? It navigate the highway at the real time and take care of the lane changing or yeah, steering handling and all those things. So the concept of automating the data, you heard more with the MLOps architecture. And I believe that MLOps architecture, when we'll talk about, which is not only the machine learning, it is all about the data processing. So how you automate your data analytics pipeline to massage your data and then feed that data into the machine learning model, take it to the prediction, so that end to end things need to address. So we talked about earlier how we are modularizing the different segment. Okay, so here we will see that we need to have this architecture loosely coupled between the data processing to the machine learning, or between the compute and storage. Then model data drift monitoring is very important, because there is a data anomalies come where your model can be shifted entirely. So let's take example in COVID. You might have built the house price prediction data or business revenue model. Okay, and suddenly COVID hit, and which never happened again. So your data doesn't have that anomalies, And what will happen? Your model will be suddenly drift, and it will give the wrong prediction because it is not trained with that kind of data. In that case, you need to validate your model often. You need to keep the track of your model and make sure that you adjust at data change. You need to adjust, and that is one, but there could be multiple example, like the supply chain disruption, and or some war in some countries can impact the global economy. Okay, so we always need to keep monitoring our model. And then you want to treat your ML ops, your ML analytics machine learning pipeline like you treat the code. So you need to have the CI/CD pipeline where you need to have code repository where you do the code review, like writing the code into the Python and R or PySpark, and deploy using the container. You can deploy the model and while going into the production, and you follow all the naming convention and standard practice here. So here example of all the artifacts generated during the data ML flow. So you can pretty much relate it from the standard DevOps pipeline, this data automation and ML ops pipeline. So a core repo where we are going to check in your code. It could be the Python notebook and Docker files or cloud formation template. Then in data repository, which is your S3, where you keep your all the data. It could be the raw data, processed data after performing the data transformation, or storing your the inference data, which is the final output. And then in model registry, you will have you can have the containers, which the container you will register and you will do the automated deployment. And last but not the least is the locks inside, audit trail, all those things you want to keep it. So how you do that? How you connect different things? So we talked about SageMaker, we talked about the S3, and we talked about the connecting with this API. So if we'll take an example of the AWS, they provide the step function, and step function is the bunch of Lambda function together, and they connect each services, and they can be very good and very helpful into the automation. So let's take the thing. So we have the step function which have the Lambda inside it, and then it can help to discover the data into the S3, load that data into the Hadoop, which is EMR, Elastic MapReduce, and perform the analytics, and put the AIML on top of that using the Amazon SageMaker. And that you can trigger using, like here I have used the event bridge, so you can schedule the triggering based on whatever event is there. Okay, some application event or any event, and then this entire pipeline will be automated. So let's look at a little bit more dive deep at the 300 level. You see that this is a standard AWS step function model. It is pretty easy drag and drop model. Okay, so you can build this flow here. You see the flow, it generate the code. And each of these green boxes you see are a function, the Lambda function. So here you see that at the left side of his screen, how these flow is automated and connected. First, you initialize the execution, then prepare your data and automate the analytics part, then train the model, validate the model, register it, and then deploy. If there is any failure, you get the notify, you do the process again, and its entire things is automated. And we are taking it and putting it more visualization. So you will see that here we are talking about the natural language processing training state machine. And here step function you used within the ML solution to arrange the data processing using the serverless workflow. And it is stitching together the SageMaker services with the help of the Lambda function, and perform the series of steps, and one step is leading to the other steps. So And is so here if you will see it is getting triggered, then starting the SageMaker processing, and then it is training the deep learning model, in this case doing the parallel training steps, and then model is getting created and deployed. And after that, if there is a success or failure, you get notified. So these are the very scalable mechanism for the MLOps. So let's put everything together. And here you see that we are putting the machine learning into the production using the MLOps. The main problem currently happening with the machine learning, lots of things in the experimentation phase. The model is getting built and trained and demoed, but little bit struggle how to productionize this, how to scale this. And here you see that we put this in the three part: build, train, and deploy. And if you'll see in the train part, we are ingesting the data, we are labeling the data. Here I used the ground truth for the data labeling. And using the AWS Lambda, we are automating and triggering the train and test job. And where the containers getting deployed with the ready to use model. And then we are doing the model, once model get deployed, we are doing the model monitoring, batch transformation, also exposing the API, RESTful API, the deployment endpoint, so that application can use that. So, and here at the CI/CD pipeline, we took these code, the SageMaker notebook code, and checked into the code commit. You can use the GitHub also. And using the code pipeline and code build, we create the model, put into the container, and push that container into the SageMaker. So now you can assume this pipeline, if it is if we are building a personalized engine. Okay, so might be this is a retail website or financial product, and through the API gateway, it getting that a model, and at this end we are ingesting the customer data, we are ingesting some behavioral data, what different kind of shopping is doing, and that's how we are getting the prediction and performing it. So, and everything is performed by, you see the different Lambda function, and as I explained earlier, these are can be orchestrated using the AWS Step Function, and then build the entire pipeline here. So this is how you do the entire data automation. So let's take a step further and talk about the IoT architecture. Internet of Things is everywhere, especially it is becoming very prominent with industrial IoT and autonomous car and the sustainability, where like wind energy is there. And currently IoT, all the small devices with the small microprocessor is everywhere, like it is your home security system, small cameras, car, everywhere it is. So there is a need of this humongous amount of data to take into the real time, and then also visualize that data and get the insight and take action on basis of that. So it is helping to increase the factory output, maximize the assets utilization, and identify the equipment maintenance issue. So, so from that, I remember I have put one screenshot here where building application to operate a jet engine maintenance into a metaverse. So you see that clearly. If you're a new worker, he can visualize each part of this jet engine. Okay, so and look into that. Okay, what kind of gear is there? What kind of pulley is there? And it is depicting the creating a digital twin of the real engine. And those engine has thousands of sensors, so that IoT data is collecting that sensor data and displaying in the background. You see that is a quick site dashboard. And if there is unexpected RPM speed or the temperature anomalies, then it trigger uh, predictive maintenance, which helps to save lots of cost. If engine fail, it is very costly. So here you see a flow of the digital twin which AWS provide through the AWS IoT Twin Maker, currently available to create a digital twin, and which create the real world replica here. And then there is various tools, IoT core to collect the data and pass through the IoT analytics, and then do some predictive analysis on that. And then it can be visualized by a quick site, as you have seen into the previous screenshot. And real-time data ingestion happening through the Kinesis. And in the factory floor, if you'll see at the monitor part, the telemetry data getting ingested through the IoT core, and then we are taking the action using the Lambda and API gateway. In the act part, you will see where if there is any need of the maintenance and all, it can go proactively create the ticket and guide into the factory floor, hey, go and fix this machine or do this maintenance or wash the engine, all those things, or do the oiling. So let's one talk go a little bit further. So the current trend you talked, you heard everywhere about the cryptocurrency, and that is not the only use of the blockchain architecture. That is a very small part of it, and that's what I call it the tamper-proof data handling, which is very important. And it also do the decentralized identity. It means that there is no central authority. It is more democratic process. There is data distributed between multiple individual, and they identify the data which have less chances of the fraud. Same, you talk about certificate registry, so you can create a tamper-proof identity management and provide the smart contract. And then industrial blockchain, it is very useful to track the source material from delivered to finished goods and all. So here is one example, the supply chain data tracking, where we embed the blockchain, and it is very important. So like take a real-time use cases. The Louis Vuitton bags are very costly, and once you are buying that, you want to make sure these are the original manufacturer. This is not some duplicate, and especially it is going through the multiple channel, starting from manufacturer to the supplier to the wholesaler to the retailer, and some end user is buying, and might be they'll resell again after some time, okay, because they want some latest stuff there. So in this entire supply chain, if you have this retail member is joined that blockchain network with supplier member and manufacturer, then you can create a tamper-proof trail of the record there, which can provide the authenticity that this is the original product. Okay, so I think this is very useful for the fashion retail, and also it is very useful the sustainability, because when the product is passing through the supply chain, you make sure that all the sustainable resources used to transport it. Okay, so this is how it is. We are combining the data analytics with the IoT, with the blockchain, and putting this holistic picture. So now, before wrapping up, I will like to talk about the quantum computing, which is peeking into the future of data, right? There is still lots of data which is unlocked. Like if you talk about the space travel, you talked about the large scale optimization, and if you talked about the genomics, right? These are things are still not completely unlocked because currently we don't have that capability. The traditional computer not able to host that large amount of data they cannot store, and that's what quantum computing revolution is coming. And it is still work in progress, so I'm assuming by next decade, by end of this decade, by 2030 or something, we should have a very stable quantum computer to perform all those things. But lots of experiment is still in progress, and it perform on the qubit rather than bit. So qubit you have 0 1 1 0, but qubit can have the multiple combination 0 1 1 0 1 1 0 0, and this is the linear vector. And then we create the quantum circuit, and quantum circuit put the qubit in superposition where two qubit can uh, perform we can draw the conclusion from each other. So there is some dependencies they can do. But this is a little bit deep topic, so I'm not going much into that. But yes, in Solution Architect Handbook, I have scratched the surface there, so you will see. But some tapping into the unsolved data problems, so like optimization and so seeing the large package delivery, traffic control, or energy storage. So route optimization is very important. So if you'll see that if UPS, FedEx, or Amazon want to optimize the route across all the city in the US, I'm just talking about the US, and they have approached entire world. There is trillions combination is there, and that kind of data is not possible to house into the traditional computer and perform the optimization algorithm. And supercomputer is fast, so if if it is taking like a 2 to the power n or n times to perform some particular calculation, that can be do by the supercomputer, the quantum computing in under root n. So it's pretty efficient. Then some machine learning model have billions of parameters, and those models are taking days to train. And I think with quantum it can be pretty fast. Same in internet search, indexing trillions of pages, or creating the simulation of genomics, complex molecular formation, or drug simulation. All those can unlock lots of value. So with that, I will come to end, and thanks for listening. And again, if you want to dive deep in each of the topics, I will encourage you to scan the QR code. I have provided tiny URL also. Grab a copy from the Amazon.com, and definitely you can find me on LinkedIn also if you want to reach out and learn more about it. Okay, and happy learning, and thanks for listening today and your